Hello everyone. This video is on the Knewton Alta assignment for section 3.7 part 2 called Find Inverse Functions. Alright, so in this video I'm going to be doing a preview version of this particular assignment. Please understand that the questions that I see in this video may not be the same questions that you see when you work on the assignment yourself, but the objectives are all the same, so the questions should be similar enough to where watching me do a few of them will help you in some way when you work on them yourself. Alright, so on the assignment page here you got the title, you got your mastery bar, see the objectives. Looks like there are 4 objectives here, so a bit longer one. Underneath the current objective, right, there should be a question related to that objective. And underneath each question, at the bottom, there should be a feedback button where you can send feedback to Knewton. You will not have an instructor cheat button. It's for instructors only. But you will have a more instruction button. Right. Now this you can click on if you're struggling with material, and you'll be taken to a page with some reading or videos to help you out and do some problems related to that instruction, and you can get through the assignment that way if you wish. Alright, so this first objective we're looking at is given a function, find the inverse function. Right. So we're told here the function, f of x equals -5 times the square root of x plus 4 and then plus 3. And remember, you can't take the square roots of negative numbers because you'll get a non-real output. So that's why over here they mentioned the domain, right? The values of x that can be plugged in here. X has to be greater than or equal to -4. It has an inverse function called f inverse of x, defined in the domain for x less than or equal to 3. Find this inverse. Alright. So I'll write this out. Got f of x equals -5 times the square root of x plus 4 and then plus 3 after. And they're telling us, and you should be able to figure this out as well, that x has to be greater than or equal to -4 in order for you to have the square root of a non-negative number. Alright, now finding inverses when you're given the equation. I'll write out the steps I like to follow here. Alright, so first, have x become y and f of x or y become x. Remember what inverses are. Inverses are just reverse mappings. So this function here is the same thing as the following if you wish. As y equals -5 times the square root of x plus 4 and then plus 3. Right? These mean the same thing, but here I'm having y be y as f of x. Right? But now we invert. Alright, now we invert. And if you recall from the section 3.7 part 1 video, which I'm assuming you've seen, right, an inverse is just a reverse mapping, right? If a value was an x value in the initial function, now it's a y value, right? Inputs become outputs. And if something was a y value or an output in the original function, now it's an input, right? Things get switched up. So instead of y equals -5 times the square root of x plus 4 plus 3, now it's x equals, right? All the y's become x's become y's. -5 times the square root of y plus 4, and then plus 3. But now here, in this equation, y is no longer f of x. Y is f inverse of x. Right? This is a new function. So we invert. Right, this is what I mean by invert. And then solve for the new y, which is going to be your f inverse. Right? F inverse of x. So I'm going to solve this for y. Now this is a radical equation. Right, so first I'd subtract 3, x minus 3 over here. Get the radical term alone, right? Negative 5 times the square root of y plus 4. And I square both sides, right? So x minus 3 squared equals, now negative 5 squared is 25 times the quantity y plus 4, right? The square root would have been gotten rid of. Then we divide by 25, subtract 4. Right? And y, which is f inverse of x, would be the quantity x minus 3 squared divided by 25, and then minus 4 afterwards. And they told us that the value of x must be less than or equal to 3. And you'll see why when I look at the graphs of these. Right? But this is what I'm going to type in. And I'll show you. Well, let's verify this. I'm going to actually go to that Desmos website, desmos.com. And we'll look at the graphs of these two functions, and you'll see that they're reflections across the line y equals x. That's something else I'm hoping you recall from section 3.7 part 1, is that the graphs of inverses are just a reflection across the line y equals x. Alright, so let's do that. Alright, so I got the Desmos website up here, desmos.com, a free online graphing calculator. So I'm going to put in the first function we were given, y equals negative 5 times the square root of x plus 4, and then outside plus 3. And you see this graph here. Alright, there's the graph we're looking at. The domain is, all the values from negative 4 to infinity on the x-axis, and the range is from negative infinity up to 3. Right, in fact, I will write that out back on the paper. So if you look at the graph of this thing, right, the domain of f was values from negative 4 to positive infinity, which they stated here. But we also saw the range. The range of f was, everything from negative infinity up to positive 3 on the y-axis. And that tells me what the domain and range of the inverse function is going to be. Again, I stated all this stuff in 3.7 part 1. Remember, the domain of f is going to be the range of f inverse. So the range, the y values that you'll see in the graph of f inverse here are from negative 4 to infinity. And then the range of f becomes the domain of f inverse. So the domain of f inverse needs to be, and that's why they already stated this for us, all the values less than or equal to 3, right, from negative infinity up to 3. And I'll make sure to put this restriction in the Desmos site. Right? Again, I'm assuming a lot here that you've seen piecewise defined functions in previous videos I've done in previous sections before. And I'll show you how to graph for, here is my inverse. Y equals, the quantity x minus 3 squared, then divided by 25, and then after that, minus 4. Now you see that graph is not the entire, it's too much, right? It's too much. If I put in the line y equals x, make that like a dashed line or something, right? Because it shouldn't belong really. Do you see how if I reflect the red graph across the line y equals x across this green dash line, I'll get part of the blue graph, but not all of it. All right, I don't get the entire thing, and that's why that's why there's that restriction. right? The restriction you put in braces, x needs to be greater than or equal to 3. Or sorry, less than or equal to 3. Close the braces, and there you go. This blue graph that just showed up, see how the furthest right point here is 3, -4? That's just the point -4, 3 on the red graph reflected across the line y equals x. Right? And every point on the red graph and blue graph are just reflections across the line y equals x. So again, that's why and again, the domain of the red graph is the range of the blue graph. And the range of the red graph is the domain of the blue graph. Right? Or whatever colors you're seeing. Right. But yeah, so that looks like, again, you can see, hopefully you can see that they do look like a good reflection across the line y equals x. So that pretty much tells me, hey, this is a good inverse here. And that's what I'm going to type in. Right? In fact, I might just copy and paste this here. I copy this, go back to the assignment, and just paste it in. Yeah, and that should be good. Great. And then after you submit an answer, it'll tell you if you're right or wrong. Give you some answer explanation. Please read through the answer explanations, whether you're right or wrong, just so you understand why you were right or why you were wrong. Especially if you're wrong, to try to figure, hopefully you can learn from your mistakes for the future. Right, and that procedure I went through, switch x's with y's, y's with x's, and then solve for the new y, that's what I'm going to do to find any inverse function. And then we'll take a look at the graphs and see if they're reflections across the line y equals x. Okay, so here, new objective. Determine the domain and range of an inverse function and restrict the domain of a function to make it 1-to-1. So again, I know this is a lot of stuff building on itself, but remember section 3.7 part 1 talked about how a function needs to be 1-to-1 in order for the inverse to be a function as well. Right? In order for an inverse function to exist. If a function is not 1-to-1, if it doesn't pass the horizontal line test, then the inverse function doesn't exist. Right? So you gotta keep that in mind. So like this one here. This function, this red graph that we're shown, is not 1-to-1. So its inverse would not be a function. An inverse function does not exist for this. So they say here, see, you want to restrict the domain of the function shown in the graph below to make it 1-to-1 so that we'll have an inverse. What are the largest domains in the interval notation you could use? Alright, so I'll draw a picture of this and explain how we can cut the domain so that we keep the same range. You want to keep the range the same, but restrict the domain so that it's 1-to-1 and we'll have an inverse that is a function. Alright, so what I've done here is I've drawn a very, very rough graph of the graph they gave us. And right now, the domain is, now these are not arrows, right? They don't go off forever. These are like, the graph stops here and stops here, these points. So the domain right now is every x value from -7 to 1. And the range right now is all the y values from -1 to +3. Right? And I'm putting brackets on these because they're all included. They all are x values or y values at some point. But this is not a 1-to-1 function, right? Because there are two x values that give me the same y value, right? These x values of -7 and 1 give me the same y value of 3, right? That's not a 1-to-1 function, and that means the inverse is not a function. Right? If I were to reverse all these ordered pairs, if I were to reflect across the line y equals x for all these points, that new graph would not pass the vertical line test. It would not be a function. Right, so again, what we want to do is keeping the same range, right, keeping the same range. So this range, I still want the y values from -1 to 3 to be used. Cut the domain so the function is 1 to 1. And then the inverse of that function would exist. And the inverse of that function would also be a function. So cut the domain so function is 1 to 1. Well, there's two ways we could do that, right? Like the left half and the right half. I could cut it into the left half where, here's -3, -1, that point, and goes up to -7, 3, and there you go. Right. So see, it's got the same range, but the domain is now just all the values from -7 and -3. Right. Or, that's not the only way I could do it. I could also do like the right half. Go from -3, -1 here up to the point 1, 3, and have that right half of that little graph. Same range, right? Keep the same range, but now it's a 1 to 1 function, right? It passes the horizontal line test, and the domain is from -3 to 1. And these are the two domains that they're talking about, right? You could cut the domain from -7 to -3 on the x-axis, and you'd get the same range and have a 1 to 1 graph. Or you could cut it from -3 to +1, and again, you'd have the same range and have a 1 to 1 graph. So these are the domains that they're talking about when what they're asking me to enter. Now they already have the brackets, so I just need to enter the numbers, right? So one of these was for the left half was from -7 to -3, and then if I wanted to make it into the right half, do that 1 to 1 piece instead. That was from -3 to +1 on the x-axis. Right, so one of those, not both, but one of those will give me a 1 to 1 function, and therefore, the inverse function would exist. And again, please read through the answer explanations. Okay, here, verify inverse function pairs algebraically. Alright. So we're asked to find the inverse of some function from the answer choices below by checking whether f composed with g of x equals x is true. So this is something that I didn't bring up, that didn't come up in section 3.7 part 1. So I'll bring that up right now. Is what happens when you compose inverses. Remember, function composition. Composing inverses. So if, say, functions f and g are inverses, then f composed with g of x will just be x. Or you could say f of g of x equals x. For all x in the domain of g. Also, the other order would work too, and this is one of the few times that switching the order when you compose wouldn't matter. You get the same result. Right, and this is for all x in the domain of f. But basically, inverses undo one another. Remember, they're reverse mappings. If a value x goes through g, right, to g of x, and then remember, if you go through the inverse, right, g inverse, which is called f, as they say, f and g are inverse. So f is g inverse, g is f inverse. It's going to take you right back. Right, so x is the same thing as f of g of x. Right, it takes you right back to where you started from. And the same thing down here, right? You start with some input x, and if you go through f, that takes you to f of x, and then you put that through g, which is f inverse, it's going to take you right back, right? Remember, f inverses are reverse mappings, so x is the same thing as g of f of x. Right? So that's what they're talking about here, right? When they're saying test, test if f composed with g of x is just x, right? This line here, because that's going to happen if functions are inverses. Right? It better happen. Alright, so I'm going to go through and find the inverse the way I did earlier, algebraically. Alright, switching x with y's, y's with x's. I'm going to call f of x y and do all that switching. Alright. So let's write this out. So we're given y equals 2x plus 9 divided by negative 3x minus 5. And again here, y is f of x. Now we're asked to find the inverse function. Right? So I invert. Right? Switch all the y's with x's, x's with y's. So y becomes x, and then these x's become y. 2y plus 9 divided by negative 3y minus 5. And then in this equation, y represents f inverse, or what they're calling g, right? They're saying let g be f inverse. Right? And then I solve this for y. Solve this for y. So like any rational thing, you have x times the, multiply by the denominator here, LCD. And then on the right side it would just cancel, multiplying both sides by the denominator. Then let's distribute this x. We have negative 3xy minus 5x equals 2y plus 9. And then we're solving for y. So let's get all the terms with y on the same side. So I'm going to subtract the 2y. We have negative 3xy minus 2y. And then all the terms that don't have y on the other side. So I'd be adding 5x. So we have 5x plus 9. And then factor the y out and divide. Right, you should get the y alone. Pull the y out, you have negative 3x minus 2 as the factor there, and then 5x plus 9 over here, and then divide. We get y equals our f inverse, or the g of x, equals 5x plus 9 in the numerator, divided by, and then negative 3x minus 2 in the denominator. And let's see which one of those match that or are equivalent to that. And that's this very first one. So that's it. Now they're asking us to verify that when you compose them, they undo each other. So I'll do that here. So again, they're calling this G, and let's compose them. All right, and this was F up top. So F here, G there. They're saying, what's F composed with G? Is F composed with G of X equal to just X? If that's the case, then there's a good chance that they're inverses. All right. Doesn't mean they are, but good chance. Okay, so basically remember how composition works. You just take G, right, this expression here, and substitute it into F. So everywhere there's an X up here in this expression, replace it with all this. So instead of 2 times x plus 9, it's 2 times this plus 9, 2 times 5x plus 9 over negative 3x minus 2. And then you got the plus 9 after. And divided by, and then instead of negative 3 times x, it's negative 3 times g, right, this thing. So 5x plus 9 divided by negative 3x minus 2 again. And then you got the minus 5, all right. And let's simplify this, and hopefully we end up with just x, right? They undo each other, they're inverses. Okay. So I'm going to multiply the numerator and denominator by this negative 3x minus 2. All right, distribute, that'll get rid of that, and multiply by 9, distribute down here. All right, so up top you got 2 times 5x plus 9. The negative 3x minus 2's would cancel. That'd be 10x plus 18. And then plus 9 times this would be negative 27x. And then minus 18. Then down here, again, the first term, the negative 3x minus 2's would cancel. Then times negative 3 would be 9x plus 6. And then times negative 5 here would be plus 15x. And then plus 10. Oops, nope. My bad. My apologies. This, the negative 3x minus 2's would cancel. You have negative 3 times 5x plus 9. I did times negative 3x plus 2 minus 2 for some reason. Negative 3 times 5x would be negative 15x. And then negative 3 times 9, negative 27. Okay, that's better. And then the negative 5 times the negative 3x minus 2 would be plus 15x. And then plus 10. So up top, we have negative 17x all together. And on the bottom, we have negative 17. And oh, look at that. Those cancel. You're left with just x. Fantastic. That's just something they ask you to do to verify that these are inverses. And honestly, if they really wanted to verify that they're inverses, they should do the other order as well. Do g composed with f and see if you get x. But you can see this can be kind of annoying. I would say if you felt, hey, I did everything correctly here when I inverted and then solved for y, just leave it at that. But if you really want to verify stuff, you should be composing in both orders. You should do f composed with g and see if you get just x back, and also g composed with f to see if you get just x back, and that would definitely verify that these two reverse each other. They're reverse mappings, they're inverses. Alright, but I already toggled that first option there, and that's what I got. Great. And again, please read through the answer explanations. Make sure that you understand what's going on, hopefully. Alright, next, now which of the following functions is the inverse of f of x equals negative 6x plus 8? Well, this is, again, very simple. I've been doing this. You just switch y's with x's, x's with y's, and solve for the new y. Right. So once again, here's the function we were given, y equals negative 6x plus 8, where this y represents f. Then we invert. Right. Reverse the mapping. So y's become x, x becomes y. But this y represents f inverse of x. And then we solve for this new y. So I'd subtract 8, divide everything by negative 6, and it looks like they write everything in fractions form. So like minus 8 and then divide by negative 6, that'd be negative x over 6, or negative 1/6 x. And then negative 8 divided by negative 6 be positive 4/3. Right, so negative x, so there's your f inverse of x right there. And again, if you want to see the graphs, maybe I should do that with this one because it's pretty easy to see. But if you look at the graphs of these two functions, they're going to be looking like a reflection across the line y equals x. And I'll show that to you. So again, back here, I'll keep the line y equals x up, right, in a dashed form. The original function we were given, right, f was y equals negative 6x plus 8. There it is in purple, or whatever color you're seeing. And then y equals, now f inverse, y equals negative x over 6, and then plus 4/3. Right? And again, I hope you can see it. This purple line, this black line, every point on the purple line, you reflect it across the line y equals x, you get on the black line here. Here this has the point 80. This graph has the point 0.8. Right, the x and y switches. This has 4/3, 0, and the black graph has 0, 4/3, 1 1/3. So the x and y switch. They're reflections across the line y equals x. They are indeed inverses. And if you were to compose them, you'd end up with just x. All right, f composed with f inverse will give me just x, just the original input back. Yeah, so that's this first option here again. Negative x over 6, negative 1/6x plus 4/3. And we kind of verified it by looking at the graphs and see that the graphs are reflections across the line y equals x. Here we're asked to use the graph of a one-to-one function to graph its inverse on the same axes, right? Remember what I told you? Just reflection across the line y equals x. They even have the line y equals x in dotted form here. And here's, y equals f, and they want us to graph f inverse. Well, just find some points on f and just switch the ordered pair and plot those on f inverse. Like the graph of f has 0, 3. So this is going to have 3, 0. So I move one of these points to 3, 0. And then it's pretty obvious. Now, again, just look where they meet at corners here. Like this is negative 4, negative 5. So switch that. Instead of negative 4, comma negative 5, the other graph's going to have negative 5, comma negative 4. Right, and you can see that here. And also, they both have the point negative 3, negative 3 on it. Wherever our graph meets y equals x, that point's going to be on both graphs. And there you go. See the blue graph and the purple graph here are just a reflection across the line y equals x. These are inverses. That should probably be the easiest thing that we're doing in this particular assignment. All right. Next question. All right, so another graph. All right. So given the plot of f of x, okay, so multiple choice one. Given the plot of, so here's the graph of f. What would be the graph of f inverse? Well, this has 0, 4. So the graph of f inverse would have 4, 0. This has negative 2, 0. So the graph of f inverse would have 0, negative 2. So whatever line, and it's a line, any reflection is going to keep the same shape. So if this graph is a line, the inverse will also be a line, but it's going to have 4, 0, and 0, negative 2 on it. So not that graph, not that graph, not that graph. This graph has 4, 0, and 0, negative 2 on it. Right? And that's the only one that makes any sense that has the ordered pair switched. This is the graph of the original one, inverted. Wonderful. Yeah, the graph stuff I feel should be the easiest of all these objectives. Okay, back to domain and ranges. This is just like earlier. The first problem in this objective, the graph of some function f is shown below, but do you see how this graph, this function is not one-to-one? So that means there is no inverse function that exists, but we'll keep the same range, right? Keep from 0 to 5 on the y-axis here, but cut the domain. And again, it's kind of a left half, right half situation. Write the domain in interval notation that you can use to restrict the domain of the function shown in the graph below to make it one-to-one so that we'll have an inverse. Well, we can go from negative 5 to 0 on the x-axis, and that'll work. You keep the same range, and now you have a one-to-one function, kind of like the left half, And then from 0 to 5 would also work. So that's what they got. But now here they don't have, the brackets. You have to put the brackets yourself, right? So from bracket negative 5 comma 0 close bracket, there's one interval that I can cut the domain to get a one-to-one piece, or from 0 to 5, right? Bracket 0 comma 5 close bracket. Either of these domains would give me a piece of this function that is one-to-one and therefore would have an inverse that's also a function. Great. But again, keep the same range though. Alright, so another one where I'm going to have to do some switching up, right? X's become Y's, Y's become X's. Alright, so I'll write this one out, just like other problems. So we're given Y equals -5 times the square root of X plus 1, and then afterwards -6, and they're telling us, you know, and it's I hope it's obvious that X needs to be greater than or equal to -1. And also, I used Y here. This Y represents F. Now we invert. Switch Y's with X's, and X's with Y's. So now we have this. X equals -5 times the square root of Y plus 1, and then -6. But this Y represents F inverse. And they're also telling us that the domain has to be values of X less than or equal to this, right? They told us this. You could also figure it out for yourself on a graph, but let's continue. And then I solve for this new Y. So I'd be adding 6, squaring both sides, and then dividing by 5, and then subtracting 1. There we go. Alright. Add 6, square both sides, divide by 25, then subtract 1. It's kind of like the problem earlier. So here's our inverse function right here, the expression for it. And that's what I'm going to type. So F inverse. And again, if you want to kind of verify that, you know, look at the graphs on a graphing calculator, on Desmos, whatever, and, you know, restrict the domain to values of X less than or equal to 6, and you'll see that the graphs are reflections across the line Y equals X. They are inverses. Or you could compose them, you know, do one composed with the other and see if you get just X back. That was another test, right? So X plus 6 quantity squared, and then divided by 25, and then after that, plus -1. That should be good. I mean, they have it written a different way, but it's equivalent to what I have. That's why mine was correct. Okay, looks like the same objective. Alright, so again, X becomes Y, F of X becomes X, Y becomes X, and solve for Y. Alright, or if you want to keep it this way and solve for X and then just make sure you switch it up at the end, that's fine too. So I'd subtract 5, you got, you know, X minus 5 squared divided by 81, and then plus 8. Alright, I'm not going to write that one out. You should be able to do that. That's pretty simple after a while. So, yeah, so X minus 5, quantity squared, divided by, you know, 9 squared is 81, and then you do the plus 8 after. Alright, and that should be good as well. And again, if you want to look at the graphs of these with the restricted domains that they have here, you'll see that their graphs are a reflection across the line Y equals X. Let's say I got one more like this. So again, I'm just going to talk it out loud. And if you want to verify at the end, you know, again, switch X with Y, replace F of X with X, solve for the new Y, or you can start off with this, solve for X, and then just make sure to switch them at the end. But we'd add 6, then square both sides, divide by 9, subtract 2. Right. So we end up with F inverse of X would be X plus 6, quantity squared, divided by 9, and then afterwards subtract 2, right, minus 2 after. And that should be good. And again, it might look a little different than what they have, but it is equivalent. Alright, so the objective there is done. That objective got, you know, 3 more to finish. Alright, so this one verify. Now again, this is just, you can do the composition at the end, or you can do what they suggest, you know, go through all these answer choices and compose them with F and see if we get X back. Because if you compose two functions and you end up with just x, there's a good chance that they're inverses. Now, if you do it in both orders, f composed with g and g composed with f, and you get x, then they're definitely inverses. All right. But I'm just going to do what I've done. Now this one I'll actually write out. These are a little more involved. I'll write it out and do the inversion and all that, switch x with y, y with x, and solve for the new y, and we'll have our inverse function. So the function we're given is y equals negative 2x minus 9 divided by negative 5x plus 6. And this y is f, right, f of x. And then I invert. Y becomes x, and these x's become y. Negative 2y minus 9 divided by negative 5y plus 6. But these y's represent f inverse. And then I solve for y. So again, I multiply by negative 5y plus 6 here. We get negative, and then distribute the x. We'd have negative 5xy plus 6x on the left. Over here it would just cancel. You have negative 2y minus 9. Get all the y's to the same side, factor it out, and then get all the terms without y on the other side. So I'd subtract 6x. I'd add 2y and then factor a y out. So you have y times the quantity, negative 5x plus 2, and then divide. So negative 6x minus 9 in the numerator, negative 5x plus 2 in the denominator, and this should be f inverse of x. And look back at the choices, see if any of those are equivalent, and this last one is. And if you were to compose them, if you were to take this expression here and replace the x's in this f function and simplify, you'd get x back. I promise you, and I'll leave that for you to check, but I'm not going to do that this time. Okay, and that's exactly what they're doing here. Right? Composing and simplifying to x. All right, and then this one here, all right, this is very simple. So I would switch the f of x becomes x, x becomes y, or f inverse, and then solve for the new y. By subtracting 3 and then dividing everything by negative 4, you get negative 1/4 x minus 3/4. Oh no, plus 3/4, because it'd be negative 3 divided by negative 4. So negative 1/4 x plus 3/4, this second option. And that would be it. And again, if you were to look at the graphs of these and Desmos or something, you'd see that there were reflections across the line y equals x. Also, if you were to compose them in either order, f composed with g, g composed with f, you'd simplify to just x. That's going to happen for inverses. Great. All right. So that objective is done. Again, we're given a graph here, and it's multiple choice, which is nice again. So this looks like one of those, you don't know what exponential functions are yet, but it looks similar to one. I don't know, it looks like it has negative 5, 0. So the inverse should have 0, negative 5. And it's not exactly exponential. They don't really, it's not showing it. It's not like going off forever this way. But so this has negative 5, 0, it looks like. The inverse would have 0, negative 5. And this has 0, 5. So the inverse would have 5, 0. And again, all these points here are reflected across the line y equals x. So instead of curling up from negative 5, 0 to 0, 5 and up, it's going to curl downward kind of from 0, negative 5 up to 5, 0 here and then beyond. So not like that one though. All right, yeah, this has negative 0. This has 0, negative 5 and 5, 0, but there are no points over here that would reflect to these points here. Looks more like this one. Yeah, this one starts off at like negative 4. This one starts off at negative 5. Yeah, not that one. Definitely not that one. So this one here, from negative 5, 0 to 5, from 0, negative 5 to 5, 0, and curling up forever. Curling this way. Again, a reflection of this graph across the line y equals x, switching the x's and y's. It's the only one that seems to fit. Great. Right, so one more of this. So again, take this and reflect it across the line y equals x. Switch all the x's and y's. So this has, negative 2, 2. So this will have 2, negative 2. Right, so 2, negative 2 will be on the graph. And this has 2, 4. So 4, 2 will be on the graph. And they'll meet, the line y equals x, they'll meet here at this like 5 comma whatever, something a little less than 5. They'll meet here. And instead of curling down, it'll be curling up because you're doing a reflection. So not that, not that. Maybe that. Yeah, so definitely this one because it's got 2, negative 2. It's got 4, 2 curling up. And it's a reflection of this. It's a reflection of this first graph across the line y equals x. X's and y's are switched. That's the only one that seems to fit. Great. All right, so that objective is done. And then the last objective to complete is, again, cutting the domain, right, so that you get a one-to-one function. That way the inverse will exist. The inverse will be a function. But again, keep the same range. Here I'd cut the domain from either negative 4 to 2 or from 2 to 8, right, to cut this into one-to-one pieces, because it's not one-to-one right now. Right? It doesn't pass the horizontal line test, but if I take just this left half, it'll pass. If I take just the right half, it'll pass. So negative 4 to 2 or 2 to 8. So this domain or this domain would be good enough to cut that into a one-to-one function. All right, and then I should have one more like this. Yeah. So, it's not like an arc, it's a V shape, but still, this function is not one-to-one. Again, if I want to keep the same range, so from 1 to 4, I want to keep that same range, but cut the domain so that it is one-to-one, right? So that the piece I'm looking at will pass the horizontal line test. So that'd be from negative 4 to negative 1 on the x-axis, or from negative 1 to 2. Right? So from negative 1 to 2 would be good, negative 4 to negative 1 would be good as well, right? Those are the two intervals I mentioned. That would cut this into a piece that's one-to-one. All right, great. All right, so hopefully all that made sense. And that was it for this particular preview of this assignment. Now, as I said at the top of the video, right, every question I saw here, you might not see these same exact questions, when you do it on your own, but the objectives are all the same. So I'm hoping the way I did these questions here helps you out in a way when you work on the assignment yourself. And thank you very much for watching.